The intersection of the terminal side of an angle in standard position and the unit circle is called the terminal point. Divide this circle into special angles 30 degrees, 45 degrees, 60 degrees, and find their terminal point. So I'm going to draw the angle of 60 degrees using this ruler here, and I'm going to start at the center and make my way to the end of the circle. And the terminal point is this point right here, where the unit circle and the terminal side of the angle intersect. And we know that it has coordinates x, y, and we need to figure out what those coordinates are. And we know that the coordinate satisfies the equation x squared plus y squared equals 1. And we also are going to use the fact that we worked with that special triangle up above in our previous video. So if I draw a line straight down, I know that this now creates a right triangle where this angle here is 60 degrees. This angle is a right angle, so that's 90 degrees, which makes this angle here 30 degrees. Now, in the previous video, we found the measurements and we solved this specific right triangle. And so because we are on the unit circle, we know the length of the hypotenuse here is 1, and we specifically solved for the other values. Let's scroll back up to remind ourselves. So the side length that corresponds to the 30 degrees is 1/2. So this length here is 1/2, and the other length here we found to be √3/2. So notice that that's exactly what the x and the y coordinates that we're looking for are. So our x coordinate is 1/2, and our y coordinate is √3/2. All right, so I'm going to leave that there, and another special angle that we want to take a look at is 45 degrees. And I'll just use a different color this time. So I'm starting at the origin, and I'm making my way to the end of where the terminal side and the unit circle intersect right here. And again, I want to find the x and y coordinates. So once again, I'm going to draw a straight line down from here to create a right triangle. And we know that this is a right angle, and we know that this is 45 degrees here. So that's going to make this 45 degrees as well. And up above, again, we worked with this particular special triangle, and we found that the lengths of the legs were both √2/2. So I'm going to go ahead and erase this, and we know that the ordered pair here is √2/2, comma √2/2. And the last special triangle that we were looking at was when it was 30 degrees. So I'll draw this here. I will draw my terminal point, which is located right there, and we want to figure out what the x and y coordinate of the terminal point are. Now, this here is 30 degrees. I'll draw my line down. We know that that's a right angle, and then this is going to be 60 degrees. And so this is the same triangle that we drew in the black. It's just oriented differently. So basically all we're doing there is we're swapping the x and the y coordinate. So that's going to be √3/2, and the y coordinate is going to be 1/2. So I'm going to go ahead and highlight our answers. These are the 3 terminal points that we were looking for. Example 1 says, show that the square root of 2 over 2, comma, square root of 2 over 2 is on the unit circle. Now, the way that we're going to show this algebraically is, remember, any point on the unit circle needs to satisfy the equation x squared plus y squared is equal to 1. So let's go ahead and use this as the x coordinate and this as the y coordinate, and we want to show that it's going to satisfy the equation. So I'm going to go ahead and plug those in. And if it is on the unit circle, then when we simplify this expression, it should come out to simplify to be 1. Let's see if that happens. The square root of 2 squared is 2. And if we square 2, that's going to make our denominator 4. And then same thing with the other one. If we square the thing inside the parentheses, that's going to result in 2 over 4. And because these have the same denominator, I can just add the numerators together. So that would be 4 over 4, which is equal to 1. Thus, we have shown that the square root of 2 over 2, comma, the square root of 2 over 2 is on the unit circle. Okay. Example 2 says the point x comma negative 1/2 is on the unit circle in quadrant 3. Find its x coordinate. So notice here that the y coordinate is negative 1/2 and the x value, we don't know what it is. We're trying to figure it out, but it tells us that it's in quadrant 3. So I just wanted to return to this unit circle that we had graphed here, and I just want to show you, if we look at this red triangle here, and if I extend this line down to the opposite direction, notice that this point here is in quadrant 3, because we know that here this is quadrant 1, here this is quadrant 2, this is quadrant 3, and this is quadrant 4. So if we extend that line there, that's going to give us a terminal point that is in quadrant 3. And if I drew a vertical line up to the x-axis like that, that would form a right angle. What do you think the coordinates of this terminal point are going to be here? Well, basically, it's a reflection over the origin, and so the x-coordinate is going to end up being negative root 3 over 2, and the y-coordinate is going to end up being negative 1/2. And so visually and on the graph, this is what helps us answer that question that we just posed. Remember, it said the x-coordinate is x, the y-coordinate is negative 1/2, and we know that the terminal point lies in quadrant 3. So the x value that we are looking for is this x value here. But let's think about how we can take another approach to this question. In fact, we're going to take an algebraic approach. So again, we know that the points on the unit circle need to satisfy this equation. And we have the y value here, so why don't we just take this and substitute it in for y? And if we do that, we'll get x squared plus negative 1/2 squared is equal to 1. And then if we square negative 1/2, that will give us 1/4. And now I can subtract both sides by 1/4, and that will give us x squared is equal to 3/4. And then if I take the square root of both sides, we get that x is equal to plus or minus the square root of 3 over the square root of 4, which ends up equaling plus or minus the square root of 3 over 2. Now, we end up getting two values for x, and so we know that there are going to be 2 points on the unit circle that have a y value of negative 1/2, and those 2 points are going to be the square root of 3 over 2 comma negative 1/2 and the negative square root of 3 over 2 comma negative 1/2. However, only one of these points is in the third quadrant. And so we have to think about which one of these is in the third quadrant. And in the third quadrant, both the x value and the y value are negative. And so we can eliminate this point here, and we can conclude then that the x value is the negative root 3 over 2. So that is our final answer for example 2.